Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe, SOC Level 1 Learning Path. This is the Network Security and Traffic Analysis module. This is the TShark, the Basics room. Learn the basics of TShark and take your protocol and PCAP analysis skills a step further. Now, if you've been following along with this particular learning path, you can see that we've gone through Wireshark. So basically, TShark is like the CLI version or the command line interface version of Wireshark. And we're about to get down deep into the weeds a little bit to cover some things, and hopefully this can be another tool you can add to your tool belt. All right, so this is some things we're going to be covering: TShark and supplemental CLI tools, main parameters 1, 2, capture conditions, packet filtering options, capture versus display filters, packet filtering options, capture filters, and then display filters. And then we're going to wrap it up with the conclusion, summary, and then just go over briefly what we already covered in this room. So without further ado, let's go ahead and dive into it. As I was saying earlier, TShark is basically the CLI version or command line version of Wireshark, created by Wireshark developers. So it has most of the features of Wireshark. And it says that, however, it can also be used like TCP dump, therefore it is preferred for comprehensive packet assessment. So it sounds like it can do just about what everything Wireshark can do plus some. So Wireshark on steroids kind of is what I'm reading here. Learning objectives: filtering the traffic with TShark, implementing Wireshark filters in TShark, expanding and automating packet filtering with TShark. Awesome. So once again, there's the VM. Hit that green start button to start it. Here's some rooms to complete beforehand. It says network fundamentals and Wireshark modules. Before starting this room, check out my channel for videos related to that information. Task number 2, and let's see what they're talking about here. Command line packet analysis hints. TShark is a text-based tool and is suitable for data carving, in-depth packet analysis, and automation with scripts. And this strength and flexibility come out of the nature of CLI tools, as the produced/processed data can be pipelined to additional tools. The most common tools used in packet analysis are below. And that's absolutely true. A lot of times with these GUI or graphical user interface tools, they're not as flexible as the command line tools, which is why you should be comfortable in the command line. If you need information on Linux command line, go ahead and search my channel for that. So let's see here: tool utility, and then you have the purpose benefit over here. Cap infos, a program that provides details on a specified captured file. It is suggested to view the summary of the capture file before starting an investigation. See, we already have one in here, so let's just type this in: cap info s and demo. All right. So it pulls up all kinds of information, as we can see here. So let's go ahead and read on. grep, we already know about grep, right? Helps search plain text data. grep is one of the most useful tools that you'll have in your tool belt in the CLI. Cut helps cut parts of lines from a specified data source. You got unique, you got NL, sed, and awk down below. Sample usage of these tools are covered in the Zeek room. Check out my channel for information related to Zeek. Open the terminal, which you already have open. You can follow along with the interactive materials by switching to the following directory, which we are in right now. And also, an easy way to get into this directory, if you don't want to navigate that way, you can just go straight to the folder here, right click it, and then open in terminal. And I'll open it right up inside of there. So let's flip back over to our terminal. Okay, so we've already ran this, and we saw all kinds of information. Question time. Find the task files already done. View the details of the demo.pcapng file with camp infos. What is the ripe MD160 value? Well, we can see it right away. It's right here. So let's just go ahead and grab it real quick and plug it in. So I'm going to right click and copy and paste it over as our answer here. Now we're done. But it has all kinds of useful information here about this particular PCAP file. Task number 3, we're going to talk about the main parameters, part 1. Command line interface and parameters. TShark is a text-based, we already know that. Okay, it says multiple built-in options are ready to use to help analysts conduct such investigations. However, learning the parameters is essential. You will need the built-in options and associated parameters to keep control of the output and not be flooded with the detailed output of TShark. The most common parameters are explained in the given table below. Note that TShark requires super user privileges to sniff live traffic and list all available interfaces, which makes sense. And you have parameter and purpose. So -H, display the help page. As with most tools, -H or --help is going to be the help page of the tool. -V, version information, same thing. -D, list of available sniffing interfaces. So for just following along here, we can do TShark -H, and I didn't put the dash in there, so let's try that again. -H, there we go. And this is -I for interface to capture live traffic. So if you want to capture on interface 1, you put -I, then 1, and then -I, then the name of the interface if you want to capture on a specific named interface there. The no parameter, just sniff the traffic like TCP dump. It's pretty useful. So here's -H here, and it has all the other parameters and such inside of here that you can reference as well. Okay, so if we want to do, let's go ahead and clear the screen, and TShark -V for version, we can see what version we have on this particular box here. See the version up here appears to be 3.2.3 for this. Okay, that's good to know. And it says let's view the version, which we've already done here. Sniffing is one of the essential functionalities of TShark. A computer node can have multiple network interfaces that allow hosts to communicate and sniff the traffic through the network. Specific interfaces might be associated with particular tasks or jobs. Therefore, the ability to choose a sniffing interface helps users decide which and set proper interface sniffing. Let's view the available interfaces in a given VM. Well, you can do that with -D, and that's true. Like you can do that with Wireshark as well. Sniff live traffic on interface. So we have this here, which will probably be using number 1. You have loopback, any, and a bunch of other ones that you can possibly pick here. Sniffing can be done with one or with and without selecting a specific interface. When a particular interface is selected, TShark uses the interface to sniff the traffic. TShark will use the first available interface when no interface is selected, usually listed as 1 in terminal. Having no interface argument is an alias for the -I1. You can also set different sniffing interfaces by using the -I parameter. TShark also echoes the used interface name at the beginning of the sniffing. So that's good to know there. So if we want to do that, we can just do just TShark by itself because it'll automatically use 1 from what we just read there. So it's pulling up all kinds of information. All right, so if we just scroll back up a little bit here, that went very quickly. Yeah. So I wonder if we can just pipe that into like more or something. Okay. So now it's a little bit more manageable, and there we go, capturing on that specific interface, which we saw there. Okay, so that's good to know. All right, let's see here. Question time. What is the installed TShark version on the given VM, which we just saw there? So if we do TShark V, we can see that was 3.2.1, or 3, sorry. This is list available interfaces. What is the number of available interfaces in a given VM? Okay, so let's clear all this out. And to get the interfaces again, it was -D. And it says 12 is listed there, so I'm going to go with 12. So there we go. And next task is 4, main parameters part 2. Okay, here's more information about parameters listed in the -H as well when we looked at the help menu. So -R is read input function, read a captured file. So if we want to do that, so let's just clear this out. Then TShark -R, and then demo pcap. There we go. And then -C, packet count, stop after capturing a specified number of packets, stop after capturing, filtering, reading 10 packets. So you use TShark -C for count, and then the number of packets you want to stop at will be 10. -W, write output a function, write the sniffed traffic to a file. -V, verbose, provide detailed information for each packet. This is similar to Wireshark's packet details pane, interesting. -Q for silent mode, suppress packet outputs on the terminal. And then -X, display packet bytes, show packet details in hex and ASCII dump for each packet. Repacket files, which you've already done here, right? So TShark can also process PCAPs. You can use the -R parameter to process the file and investigate packets. You can limit the number of shown packages -C, okay? And if we want to do that, we already did -R here, right? So let's go ahead and clear this out, and then we can just do the change this R to C and just do 2 like they have on the screen there. And what did I do? You need both of them in there. If I can pay attention. Okay, so we're going to scroll back up to -R. Now we can try it with -C, which makes sense because you're reading it first and then you want to stop at 2. So there we go. Okay, write data. TShark can also write the sniffed or filtered packets to a file, you can save the sniffed traffic to a file using -w. This option helps analysts to separate specific packets from the file/traffic and save them for further analysis. It also allows analysts to share only suspicious packets/scope with higher level investigators. Pretty interesting there. So if we want to do that, of course, -r to read it first, -c one, so they're going to get that first packet, and -w right to demo pcap. That's interesting. Okay, so we can just try it, follow along here. All right, so we already have that, so let's just change this 2 to 1, and then -w, and then we'll just call it write to demo. Okay, there we go, and it should be there. Awesome. And then now we could do TShark-R to read it. And there we go. Awesome. So let's see here. Show packet bytes, which is that -x parameter. And it does look like what we saw in Wireshark's pane there, right? So if we want to do that with we'll just do the same one. We'll change this to let's see here. Yeah, so we all we have to do is add the -x at the end of it. So -x. If I can put a space in there. And I accidentally deleted the P, so let's do this. There we go. All right, so once you use this parameter, all packets will be shown in hex ASCII format. Therefore, it might be hard to spot some anomalies at glance. So using this option after reducing the number of packets will be much more efficient. Okay. Verbosity, default TShark packet processing and sniffing operations provide a single line of information and exclude verbosity. The default approach makes it easy to follow the number of packets processed sniffed. However, TShark can also provide verbosity for each packet when introduced or instructed. Verbosity is similar to Wireshark's packet details pane. As verbosity offers a long list of packet details, it is suggested to use the option for specific packets instead of a series of packets. Okay, so this one is like the pane, not the one up here. This one just shows you in like kind of I guess a little bit human readable on the side here. But let's try this one here. So once again, let's clear all this stuff out of here. Okay, I'm just gonna up arrow, and then so they did demo again. All right, so we have similar output as they have there on the screenshot. It's pretty neat to know all kinds of information that you could possibly use in an investigation here. So verbosity provides full packet details and makes it difficult to investigate long and complex terminal output for each packet. However, it is still helpful for in-depth packet analysis and scripting, making TShark stand out. Remember, the best utilization time of verbosity is after you filtered the packets. You can compare the above output with the below screenshot and see the scripting, carving, and correlation opportunities you have, right? So that's what they're talking about here. TShark CLI versus Wireshark GUI, and you can see that the similar output there. Awesome. Okay, and questions here, so go ahead and try to answer them yourself. You should be able to answer them. And if you get stuck or just want to continue on, just come back to the video once you've already at least made a valid effort to try to answer these questions. So go ahead and pause the video, try to answer these questions, come back, and we will continue on. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking. Enjoy the video. Okay, let's go and take a look at these questions. Hopefully you're able to answer them yourself. If not, we're going to step through it right now. Read the demo.pcap.ng file with TShark. What are the assigned TCP flags in the 29th packet? So we have tshark-r to read it, and then demo.pcap.ng is going to be the file we're reading, then -c for the count, and then 29 is what we're going to go to. All right, so let's take a look here, and the assigned flags is going to be push and ACK, as we can see right there. Okay. Next one says, what is the ACK value of the 25th packet? So if we take a look at packet 25 here, we can see where when equals 966, or sorry, the ACK value is going to be 12421. Also got the next one where we look at need to find the win value of packet number 9. So we'll scroll up for that one. And that's going to be when equals 9660. So there we go for those. Task number 5, we're going to talk about capture conditions. Capture condition parameters. As a network sniffer and packet analyzer, TShark can be configured to count packets and stop at a specific point or run in a loop structure. The most common parameters are explained below here. So we have parameters and purpose. Define capture conditions for a run or a single run / loop stop after completing the condition, also known as auto stop. With the -a duration, sniff the traffic and stop after X seconds, create a new file and write output to it. So tshark-w to write, and then test.pcap, then -a, and then duration is 1. File size, you can do by file size, stop after X amount of file size, so they have it set to 10 there. And files stop after X files, so stopping after 3 files. File size is 10, then 3 files as well. So ring buffer control options to find capture conditions for multiple runs or loops, infinite loop. So now would be the -v parameter. Duration, sniff the traffic for X seconds, create a new file and write to it. File size, so this is similar to what we just saw in A here from what I can see here. All right, so that's good to know. Capture condition parameters only work in the capture/sniffing mode. And let's see here. Well, B is a little bit different. So it says define, like files, it says define maximum number of output files. Rewrite the first/oldest file after creating X files. So there are slight differences between A and B there, but we can see from what we just read from both of them. But anyway, it says you will receive an error message if you try to read a PCAP file and apply the capture condition parameters. The idea is to save the capture files in specific sizes for different purposes. During live capturing, if you need to extract sorts of packets from a specific capture file, you need to use the read and write options discussed in the previous task. Hence, TShark combining auto stop, which is -a parameters, with the ring buffer control parameters -b. You can combine the parameters according to your needs. Use the infinite loop options carefully. Remember, you must use at least one auto stop parameter to stop the infinite loop. So I wonder what happens if you don't stop it, right? But we don't want to find that out, right? So let's just see if we can just follow along here. And so TShark. All right, so everything's set here. Let's go ahead and run it. Got it. Okay, there we go. We have a couple there listed. Okay, so question time. Pause the video once again, try to answer these questions yourself, then come back and we will continue on. Let's take a look here. Which parameter can help analysts create a continuous capture dump? Remember, they're talking about -a and then -b here. -b is the one we're looking for here. This ring buffer control is the one that we can do to do that. And you can also click the hint, and it'll tell you that here ring buffer controls can help analysts to create queries that can run in an infinite loop. Can we combine auto stop and ring buffer parameters with TShark? Yes, we can, as we just did and read about earlier. We can combine them together. So let's see here. Task number 6, packet filtering options, capture versus display filters. Well, we didn't actually do this, right? We just read about how we could do combine these two right here. I believe in this hint is where it explains that. But anyway, we get the gist of it. So next one we're going to talk about is packet filtering parameters, capture and display filters. There are 2 dimensions of packet filtering in TShark. We have live, post-capture. These 2 dimensions can be filtered with 2 different approaches using a predefined syntax or Berkeley packet filters. TShark supports both, so you can use Wireshark filters and BPF to filter traffic. As mentioned earlier, TShark is a command line version of Wireshark, so we will need to use different filters for capturing and filtering packets. A quick recap from the Wireshark package operation room. And in that room, we learned about capture filters, live filtering options. This purpose is to save only a specific part of the traffic. It is set before capturing traffic and is not changeable during live capture. Then we have display filters, post-capture filtering options. The purpose is to investigate packets by reducing the number of visible packets, which is changeable during the investigation. Capture filters are used to have a specific type of traffic in a capture file rather than having everything. Capture filters have limited filtering features, and the purpose is to implement a scope by range protocol and direction filtering. This might sound like bulk/raw filtering, but it still provides organized capture files with reasonable file size. The display filters investigate the capture files in depth without modifying the packet. What I'm used to doing or dealing with are these display filters in the real world. So I already have like a PCAP file saved, and then I'm just analyzing it via Wireshark with these display filters. Then we have -F here, capture filters, same as BPF syntax and Wireshark's capture filters. -Y, display filters, same as Wireshark's display filters. Check out the Wireshark packet operations room, task form 5, if you want to review the principles of packet filtering, or check out my channel about Wireshark. Another questions here. Okay, so which parameters used to set capture files, and then which parameters used to set display filters? Well, we know -F from up there. We can tell that's used for this one, and then the other one for display filter is going to be -Y. Okay, next task is 7, and then packet filtering options, capture filters. Wireshark's capture filter syntax is used here. The basic syntax capture/BPF filter is shown below. You can read more on capture filter syntax here and here. Boolean operators can also be used in both types. So we have qualifier and detailed and available options. So type, target, match type. You can filter IP addresses, host names, etc. Note you don't set a qualifier. The host qualifier will be used by default. So if host, net, port, port range, we have a variety of these we can set here. And then filtering a host, TShark-F host, and then at the IP address here, they have a range, and then port range. Direction, target, direction, or flow. Note that if you don't use a direction operator, it will be equal to either and cover both directions. That's cool. So you can set the source, destination, target protocol, self-explanatory, target whatever protocol. You have ARP, Ether, ICMP, etc. there. So this is pretty straightforward so far. Filtering MAC address, Ether host, and then of course the MAC address there that you want to filter on. Okay, this is pretty interesting stuff. We need to create traffic noise to test and simulate capture filters. We will use the terminal instance to have a split screen view in a single terminal. The terminator will help you craft and sniff packets using a single terminal interface. Now run the terminator command and follow the instructions used or using the new terminal instance. First run the given TShark command in terminal 1 to start sniffing traffic. Then run the given curl command in terminal 2 to create the network noise. It says view sniffed packets results in terminal 1. Okay, so I guess we can just go ahead and try this. All right, so we have terminated there. Hit enter. Let's bring up the screen here. Okay, so let's just copy and paste this over. Okay, and copy this over as well. This is capturing. Okay, let's go ahead and paste this over. All right. Okay, that's pretty interesting. And we have the information there. As you can see the GET request and everything there. Cool. Before being comfortable with the command line and TShark filters requires time and patience. You can use the below table to practice TShark capture filters. So if you want to do host filtering, you can use curl to a domain, as shown here, capturing traffic to a specific or traffic to or from a specific host. That's interesting there. And then IP filtering, capture traffic to or from a specific port. We will use the netcat tool to create noise on specific ports. So go ahead and try these yourself as well as we're following along here. All right, Traffic generation with netcat. Here, netcat is instructed to provide details, and timeout is set to 5 seconds. TShark capture filter for specific IP address. Okay, and then with port filtering, capture traffic to or from a specific port. We will use netcat tool to create noise on specific ports, and we can see they create noise on port 4444 there, and then it says timeout set to 5 seconds, and they're capturing on port 4444 with TShark there. You have protocol filtering here, capturing traffic to or from a specific protocol. We will use the netcat tool, and they're looking at UDP here. Okay, that's pretty neat. Question time. Once again, pause the video, try to answer the question yourself, then come back to the video, and we will continue on. What is the number of packets with send bytes? So basically, just go through and you count the number of send packets. So we have 1 and 2, and there's no more inside of here. Okay, so remember, you have to run this tshark-f and then host 10.10.10.10. Okay, so basically just copy and paste what was over here, as we saw in the screenshots earlier. What is the number of packets sent to the IP address 10.10.10.10? So that's going to be our destination. So let's see here. We have 1, 2, 3, 4, 5, 6, and 7 as the last one there. Okay, and then it says, what is the number of packets with ACK bytes? So 1, 2, 3, yeah, 4, 5, 6, 7, and 8. There we go. So 8 should be our answer there. Task number 8, packet filtering options, display filters. Now, an easier way to do this is to, when you run this, you can save this as an actual file, as we learned earlier with that -w option, and then you can pipe it into grep. And then with grep, you can filter on like syn or ACK, and then they'll probably be easier to read than just trying to read it like this, like I did. But anyway, task number 8, packet filtering options, display filters. Wireshark's display filter syntax is used here. You can find more about it, this link here. Additionally, you can use Wireshark's built-in display filter expression menu to break down protocols, which we saw in our other Wireshark videos. Note that Boolean operators can also be used in both types of filters. Common filtering options are shown in the given table. Note using single quotes for capture files is recommended to avoid space and bash expansion problems. Once again, you can check the Wireshark pack operations room, task form 5, or check out my video, and you want to review the principles of packet filtering. Okay, so protocol, IP, and then some filtering options would be here. So tshark-y, IP dot addr equals the IP. You have one for network range, source IP with the dot source or src, and destination dot dst. So this is very, as I said here, it's pretty much what we're using inside of Wireshark when we had the display filter bar at the top there. TCP, same thing here. Okay, HTTP and DNS. And it says we will use the demo.pcapng file to test display filters. Let's see the filters in action. So let's get out of this here. Close terminals. Okay, let's just clear everything out. And I'm just going to copy and paste this over. Okay. Filtering on this IP address here. The above terminal demonstrates using the IP filtering option. TShark filters the packets and provides output. In a terminal, it is worth noting that TShark doesn't count the total number of filtered packets. It assigns numbers to packets according to the captured time, but only displays the packet that match our filter. That's right. Now with Wireshark, it would tell us this information, the number of display packets. So that's one thing to note there, as stated in this information. Look at the above example. There are two matched packets, but the associated numbers don't start with 0 or 1, 13, and 17 are assigned to these filter packets. Keeping track of these numbers and calculating the total number of filter packets can be confusing if your filter retrieves more than a handful of packets. Another example is below here, and they're looking for HTTP traffic here. Okay. Awesome. So you can use the NL for new line command to get a numbered list of our output. I'm pretty sure that's a new line. Therefore, you can easily calculate the total number of filtered packets without needing or being confused with assigned packet numbers. The usage of NL command is shown below. So they're piping that into NL, right? And it looks a lot better than what we saw there. So let's go ahead and clear all this stuff out. Paste this in. There we go. 1, 2, 3, and 4. Awesome. So we have questions again. Go ahead and try to answer these questions yourself. Come back to the video, and then we will continue on. So once again, we're taking a look at the demo.pcatng file. What is the number of packets with this IP address here? This 65.208.228.223. So we can do that with the tshark-r because we're reading that demo pcat file -y because we're using the display filters similar to Wireshark, right? And then IP.addr equals to the IP address in question. And then we're piping it into NL to give us that number of packets, right? Because remember, if we do this by itself, it won't count the number of packets for us by default. You have to put the NL in there. And we can see 34 is what we get back here. So there's our answer for that one. And then our next one is, what's the number of packets with TCP port 3371? Okay, so once again, we're going to pipe things into the NL. So I'm just going to up arrow here. And we can do that with TCP.to-port equals to 3371 because we are looking for TCP port number 3371. Piping that into NL again so we can get that number of packet count. And it's going to be 7, as we can see there. Next one says, what is the number of packets with a 145.254.160.237 IP address as the source address? So let's go ahead and clear this out and up arrow. Okay, and we're looking for the source IP address, so we can do that with IP.src for that display filter option, and then equals to the IP address in question. Once again, we're piping it into NL, so we can get that number of packets. Hit enter, and 20 should be our answer there. And the next one says we run the same query again, and then what is the packet number of the duplicate packet? Now for this one, you click the hint here, and it gives you a hint of says duplicate packets are known as TCP/UDP dupe or whatever. So with this one, what I did was piped it into grep with that information, as we'll see here in a second, right? So I'm running the same query again, except I'm piping it into grep, and I'm looking for DUP or duplicate, right? See that information here, and it comes back with packet number 37 is our answer there, and we can see the dupe here on the side. Okay, that's pretty cool stuff here. And conclusion, congrats, you just finished the TShark the Basics room. In this room, we cover TShark, what it does, how it operates, and how to use it to investigate traffic captures. Now I invite you to complete the TShark CLI Wireshark Features room to boost your CLI packet hunting skills by implementing Wireshark Features with TShark. Before we wrap it up here, remember that there's another website out here that you can utilize called Malware Traffic Analysis if you want more practice on this PCAP information. It's a site for sharing packet capture PCAP files and malware samples. Okay, they have all kinds of stuff in here. It's pretty good. They have over here some tutorials, workshops, so you can click on that. It takes you to that information there. If you want the actual practice exercises, click on this one here for training exercises to analyze PCAP files of network traffic. All right, click here and they have a plethora of different files you can go through, and they want you to start from top to bottom, okay? Because things change over time. But this is just extra homework if you want to learn more about utilizing TShark or Wireshark to analyze PCAPs. So we're going to wrap this up, hit the complete here. And if you enjoyed this video, be sure to like, comment, subscribe with that notification bell so you know every time I post to the channel. All that good stuff helps grow our community here, helps keep the channel growing. And as always, thank you for your time. Thank you for watching. Have a nice day, and I will see you in the next video. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe SOC Level 1 Learning Path, Network Security and Traffic Analysis Module, TShark, CLI, Wireshark Features. Take your TShark skills to the next level by implementing Wireshark functionalities in the CLI. Awesome. Hopefully you're having an awesome day today and ready to learn something. So let's just take a quick peek here. I'm going to get into statistics part one, part two, streams, objects, and credentials, contains matches and fields, extract information, and then we're going to wrap it up with whatever we learned in this room. Hopefully y'all are excited. Without further ado, let's go ahead and dive into it. Task 1, Introduction. In our first room, TShark the Basics, we covered the fundamentals of TShark by focusing on how it operates and how to use it to investigate traffic captures. In this room, we will cover advanced features of TShark by focusing on translating Wireshark GUI features to the TShark CLI and investigate events of interest. Go ahead and check out my video about TShark the Basics if you're interested in that. Start the machine. I've already done it. Just click that green Start Machine button. The tasks for this files are located in this directory here, which I'm already in. So make sure you navigate to the correct directory here. Task number 2, command line Wireshark Features 1, Statistics 1. At the beginning of this module, we mentioned that TShark is considered a command line version of Wireshark. In addition to sharing the same display filters, TShark can accomplish several features of Wireshark as explained below. 3 important points when using Wireshark-like features. These options are applied to all packets in scope unless a display filter is provided. Most of the commands shown below are still live versions of the Wireshark features discussed in Wireshark Packets Operations Task 2. TShark explains the parameters used at the beginning of the output line. For example, you'll use the PHS option to view the protocol hierarchy. Once you use this command, the result will start the packet hierarchy statistics header. Awesome. Okay, so we have a parameter and purpose, color or dash dash color, Wireshark like colorized output, TShark dash dash color. Okay, pretty straightforward. Statistics, there are multiple options available under this parameter. You can view the available filters using the parameter with tshark-z help. Let's see what this looks like first before we continue on here, see if we need to do anything. Okay, well that's loading up. I'm gonna get the next one ready to go here. And okay, so you have to do something else there. All right, so I'm gonna kill this and fire off this help. And I have another one that says sample usage, tshark-d filter. Okay, so you have to use this in combination with something else. Each time you filter the statistics packets as shown first, then the statistics provided, you can suppress packets and focus on the statistics by using the -q parameter. I'm assuming that means quiet. All right, colorized output. And we have a color pcap here, so I'm just going to copy this and paste it over here. TShark can provide colorized output to help analysts speed up the analysis and spot anomalies quickly. If you are more of a Wireshark person and feel the need for a Wireshark style packet, highlighting this option does that. The color option is activated with the dash color parameter as shown below. And this is pretty neat here. This does look like something from Wireshark. If you ever played around with it, or you just check out my videos on it, and you'll see that um, that it looks like similar output, right? Okay, so statistics, protocol hierarchy. Protocol hierarchy helps analysts to see the protocols used, frames, numbers, and size of packets in a tree view based on the packet numbers. As it provides a summary of the capture, it can help analysts decide the focus point for each or for an event of interest. Use the -QIO PHS and then the -Q parameters to view the protocol hierarchy. So I'm just going to copy and paste this over, and we should have output like this. So let's go ahead and clear all this out here. So we're already learning some useful things with this TShark stuff. All right, so we have similar output here. We can see everything we're talking about, frames, bytes, etc., etc. Okay, pretty nifty there. After viewing the entire packet tree, we can focus on a specific protocol as shown below. Add the UDP keyword to the filter to focus on UDP protocol. Okay, and I'm assuming you do the same for TCP as well, right? So let's go ahead and clear all this stuff out. Paste this over. Okay, there we go. Awesome. So I'm just going to try TCP and see if it shows us anything for that. Awesome. So there we go. Thing we're going to talk about is statistics packet lengths tree. The packet length tree view helps analysts to overview the general distribution of packets by size in a tree view. It allows analysts to detect anomalously big and small packets at a glance. The dash z plan tree dash q parameters to view the packet length tree. So let's go ahead and do that here. Okay, pretty cool stuff right there. Statistics endpoints. The endpoint statistics view helps analysts to overview the unique endpoints. It also shows the number of packets associated with each endpoint. If you're familiar with the Wireshark, you should know that endpoints can be viewed in multiple formats. Similar to Wireshark, TShark supports multiple source filtering options for an endpoint identification. Use the dash Z endpoints IP-Q parameters to view IP endpoints. Note that you can choose other available protocols as well. Filters for the most common viewing options are explained below. So yeah, similar to what we saw on Wireshark, right? So you have ETH, IP, IPv6, TCP, UDP, and WLAN for different protocols you can take a look at here. Pretty cool stuff here, and have an example that I'm going to run. So let's go ahead and copy and paste this out. Okay, be sure to play around with these as well. Don't just um, pick a few of them. I would recommend checking out all these. Maybe they could be useful to you in some form or fashion. So I'm just going to try out a couple of them here. Okay, and here's another one here that we're going to try out here. Let's just do WLAN if there's anything in there. Okay, no packets there. And okay, let's try one more. Let's just do TCP here. There we go. All right, next one is conversations. The conversations view helps analysts to overview the traffic flow between two particular connection points. Similar to the endpoint filtering, conversations can be viewed in multiple formats. And this filter uses the same parameters as the endpoints option. Use the -v conv IP-q parameters to view the conversation. So let's go ahead and try this out here. And it says we can use the same filters up here, I'm assuming, right? So let's go ahead and try out a couple of these here. Let's try this first one. Okay, the first one's IP, and then let's try ETH. There we go there, and then let's try the TCP one. Cool. All right, that's pretty cool stuff here. Nice. Okay, expert info. The expert info view helps analysts to view the automatic comments provided by Wireshark. If you are unfamiliar with the Wireshark expert info, visit task 4 in the Wireshark the Basics room of the Wireshark module, or you can check out my channel and look at the video for that. Use the -v expert or -q parameters to view the expert information. So let's go ahead and do that here. Make sure you're all taking notes as well as we are going on in this lab here, because you'll probably have to reference them in the questions below. All right, cool. So we have nodes, frequency, chats, a bunch of other stuff in here. You have some GET requests, all kinds of stuff up here in that summary. All right, speaking of questions, we have a few here to answer here. So be sure to pause the video, try to answer these questions yourself, then come back to the video, and we will step through it together. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Welcome back. Let's go through these questions together. Use the right demo PCAP to answer the questions. What is the byte value of the TCP protocol? Now to get that, we're going to use the -QIO, then PHS-Q parameters to view the protocol hierarchy to get that information here. So I've already have it output here. And now we can see that TCP is going to be byte 62 for that one. And the next one says, in which packet lengths row is our packet listed? And to get that information, we'll have to use the tree parameter, okay? So I am just going to clear this, and then I'm just going to up arrow, to that, where we use a tree like so. So we have the dash Z plant and then tree in there. So now we'll just go ahead and just review the rows here and such. And since we know that it's going to be packet 62, we can already see that it looks like it's going to be in this range here, 40 to 79. And we can see 62 listed over here as well, right? So that's your answer there. Next one is, what is the summary of the expert info? We have to use the expert right parameter to get that. So let's go ahead and do that. Go ahead and clear this out here. I'm going to up arrow to find expert. There we go. Hit enter, and then now we can see the summary, and we see connection established, request send server port 80. It's going to be our answer there. Next one, we need to use the demo.pcapng file to answer this question. Okay, list the communications. What is the IP address that exists in all IPv4 conversion or conversations? Enter your answer in defanged format. Now, to get the defanged format, remember you can use cyberchef. Okay, so first off, let's clear this out, and then let's go ahead and find that information here. Right, so we can use the conv, right, to get those conversations in IP to get that information there. So let's go ahead and do that. I'm going to up arrow until I find it. Okay, I put IPv4. I don't think it matters, but you should still get the same results here. And the one that's referenced in all these is going to be this .237 here. As you can see, it's referenced in all of these. Okay, so what you're going to do is just copy this here, and you're going to plug it into a tool like CyberChef or whatever tool you want to use, and then you're going to use this defang your IP address, right? And then once it's in there as a recipe, it'll generate this output, and just copy that and then plug it in as our answer. All right, so we're done with that task. Task number 3, we're going to talk about statistics, part 2. To specific filters for particular protocols. There are plenty of filters designed for multiple protocols. The common filtering options for specific protocols are explained below. Note that most of the commands shown below are CLI versions of Wireshark features discussed in Wireshark Packet Operation Task 3. So go ahead and check this out, or you can look at my video to reference statistics IPv4 and IPv6. It says having the protocol statistic helps analysts to overview packet distribution according to the protocol type. You can filter the available protocol types and view the details using the -z, p-type, tree, and -q parameters. Okay, so let's just go ahead and grab that and try it out here. We should get the same output as shown in the screenshot there. So let's see if we do. And there we go. All right. Having the summary of the host in a single view is useful as well, especially when you are working with large captures. Viewing all hosts with a single command can help you detect an anomalous host at a glance. You can filter all IP addresses using the parameters below. So IPv4, you can do it this way with IP and then underscore host, then tree, and then for IPv6, you just put IPv6 and then host, tree, etc. So they're looking at the IPv4 here. So let's go ahead and grab that, plug it in. Okay. Oops. If I paste it, it would be helpful. Okay, let's try this again. All right. So looks good. Let's just do IPv6, see if there's anything there. Okay, looks good. All right. This is invalid argument. What did I do wrong here? Let's try this again. All right, I'm just going to up arrow here and see my syntax. I forgot the V in there. That's what happened. So put that V in there. All right, and there's nothing for IPv6. Okay. Next one says for complex cases and in-depth analysis, you need to correlate the finding by focusing on the source and destination IP addresses. You can filter all source and destination IP addresses using the following parameters. So IP, and then source DST tree, and then IPv6, source DST. Okay, so let's go ahead and try this one for IPv4, since you know 6 is not in there apparently, from what I can tell at least. There we go. And you can see that it's broken down into that source and destination, right? So source up here and then destination down there. Pretty cool. In some cases, you will need to focus on the outgoing traffic to spot the used services and ports. You can filter all
outgoing traffic by using the following parameters: dest and then IP6 dest. Okay, so let's just go ahead and try this first one here. All right, there we go. Destination and ports. Sweet. We have the IPs right there, and then we have the ports over here. Pretty cool stuff here. Well, actually, there's other ports here. So, yeah, the ports are listed right there. Okay, cool. Yep, port 8, they're right underneath each other. Okay, that's cool. DNS. This option provides statistics on DNS packets by summarizing the available info. You can filter the packets and view the details using DNS and tree. So let's go ahead and do that here. Cool. So let's scroll up a little bit, and we can see all kinds of information regarding DNS activity. Right, we have query, payload size, and some other things listed as well. All right, HTTP, and it says by summarizing the load distribution, request packets, and status info, you can filter the packets and view the details using the parameters given below. All right, so packet and status counter of the HTTP, packet and status counter HTTP2, load distribution, request and responses. So let's go ahead and try one of these out. Okay. And we are just doing the first one, it looks like here. So let's go ahead and clear all this stuff out, paste it in. Cool. All right. Actually, let's try another one real quick just for fun. So let's replace HTTP with, let's see here. Let's try HTTP and let's do requests. There we go. Cool. Pretty good stuff here. Okay, looks like it's question time. Once again, you know what to do. Pause the video, try to answer the question yourself, then come back to the video and we will step through it together. Okay, let's take a look at these questions. Use the demo.p cap and g to answer the questions. What is the IP address that has 7 appearances? Enter your answer into defang format. Remember, you can use CyberChef to do that or the command line to do that as well. So let's hop over to our VM and get that information here. Remember, we can use IP host to get that. So if we take a look at our notes here, we can see that this reference up here. It says that having the summary of the host in a single view is useful as well, especially when you are looking or working with large captures. Viewing all hosts with a single command can help you to detect an anomalous host at a glance. You can filter all IP addresses using the parameters given below. So I'm going to use this top one there. Okay, hit enter. All right, just double check my notes real quick. All right, and then when you get the one that has 7, so if we look at count here, go down to 7, we'll see that this .99 IP is what we reference. So remember, you need to put that into CyberChef or some other tool to defang it and then plug it in. So what is the destination address percentage of the previous IP address? So we're going to be looking up this one here and looking for the destination address percentage. And to do that, we can use this IP source DST to get that one. And there's, I believe there may be another one we can use as well, but this is the one I used here. Does that we can do this does correlation to find the focusing on the source and destination IP addresses. You can filter all source and destination IP addresses using the parameters below. Okay, so let's just go ahead and do that. I'm going to up arrow here. Okay. All right, so this will get you the source and destination, but we only need the destination, right? All right, so and the IP was this .99. And if we scroll over here to the percentage part, we can see that it's going to be the 6.98% for our answer there. Next one says, which IP address constitutes 2.33% of the destination addresses? Enter your answer in defang format. So once again, we just reference this again since we're already using source and destination, right? So we'll take a look at the destination part here. And then the 2.33% appears to be this one here, this .203 IP address. So put that in defang format, plug it in as our answer. Last one here says, what is the average queue name length? So this is referencing DNS. And then if we take a look at our notes here, it says that this option provides statistics on DNS packets. By summarizing the available info, you can filter the packets and view the details using the -d DNS tree parameters. All right, so let's clear this out, and then I'm going to up arrow to that. Okay, there it is. Hit enter. And then we need to look for qlen, which is right here. And then we're going to need the second option, or this option up here in this column, right, which is average. And if you want to get real fancy with it, you can probably grep this, right? So we'll look for q, so we're going to put grep, and then qlen, I believe that's what it was. Oh, qname len, okay. Qname, and then len, I believe, in lowercase, right? Capital L. Make sure we get this in here correctly. So there we go. Awesome. So let's go ahead and clear this out to get ready for the next one. Number 4 here, Wireshark Features Part 3, Streams, Objects, and Credentials. There are plenty of filters designed for multiple purposes. The common filtering options for specific operations are explained below. Note that most of these commands shown below are CLI versions of the Wireshark features discussed in the Wireshark module. So the follow stream, this option helps analysts to follow the traffic stream similar to Wireshark. The query structure is explained in the table given below here. And it says to follow main parameter is going to be -z, and then you can select your protocol, the view mode, stream number, and additional parameters here. Note, stream start from 0. You can filter the packets and follow the streams by using the parameters given below. So if you want to follow TCP, you can do it with TCP, UDP, and then HTTP there. And they're putting this in ASCII format, right, for view mode. Okay, let's go ahead and follow along here, and we're going to be looking at this demo PCAP again. Follow TCP, ASCII, and then 1. Okay, so let's go ahead and take a look there. Cool. Right, just like how we would see in Wireshark, right? If we're looking at that follow stream information there. Okay, pretty cool stuff. Export objects. This option helps analysts to extract files from DCOM or DICOM, HTTP, IMF, SMB, and TFTP. The query structure is explained in the table given below. So main parameter --exports -objects. And here are the protocols listed, right? And then target folder. Target folder save the files, the -q for additional parameter. It says you can filter the packets and follow the streams by using the parameters given below. And this is what they're using here. They're putting it home Ubuntu desktop extracted by TShark, then Q, and there's already a folder in there called that. Okay, and here's an example. The output that we should see, right? Okay, so let's go ahead and follow along. So I'm gonna copy this whole thing here. I forgot to put TShark -r and everything. So let's go ahead and clear this out. Okay, here we go. All right, so now it should be in there, and we're gonna put ls on there to list that information. Okay, and there we go. Pretty neat stuff there. It was able to pull that information out of there. So we have to download that HTML file there. Cool. All right, credentials. This option helps analysts to detect and collect clear text credentials from FTP, HTTP, etc., etc. You can filter the packets and find the clear text credentials using the following parameters. So these -z credentials -q to do that, and we're going to pull it on this credentials PCAP file here. Okay, so let's go ahead and clear this out. Let's make it nice and clean. And there we go. Nice. Pretty cool stuff here. All right, looks like we got some more questions. Y'all know what to do. Pause the video, try to answer them yourself, then come back to the video and we'll step through it together. Let's take a look at these questions. Use the demo.pcapng file to answer the questions. Follow the UDP stream 0. What is the node 0 value? Enter your answer in defang format. Once again, you can use CyberChef to defang information such as IP addresses or URLs. Okay, so let's go ahead and take a look here. And remember, if we just look at our notes here, we can filter packets and follow the streams by using the following parameters. So the -z to follow, or -z follow, and then UDP, and then ASCII, and then 0, or whichever one you want to pick there, right? And the one we want to pick is going to be 0. So hit Q, and then we can see that it's referencing node 0 up here, and then we can see that information. So there's .237, and then the colon, then the port is going to be 3009. So remember, put that in CyberChef to defang it, or use the command line to defang it.
Next one, we're going to look at HTTP stream 1, and then we're going to look at this refer value and defang it with TyberChef or another tool. Okay, so let's go ahead and do that here. So it's basically pretty much the same command, so we're going to change little things around. Instead of UDP, we're going to use HTTP and then change the 0 to 1. Okay, so I'm just going to up arrow here. And also, since we know that we're looking for the refer, you can just grep it. Okay, so we have follow HTTP ASCII and then 1, and you just grep it. Otherwise, you're going to get a ton of information. See how easy this is and how clean this is? Now, if we take that grep out of there, you can see that pulls up a lot of stuff that you have to sift through and then try to find that. Okay, so it's a lot cleaner when we use grep. And you can also just scroll up here. Okay, it's going to be at the top here. All right, so there's that one. And then let's check this next one here. Use the credentials.pcap to answer the questions. What is the total number of detected credentials? Remember, it does use certain protocols to get credentials. So FTP, HTTP, IMAP, POP, and SMTP. So you can filter the packets and find the clear text credentials using the parameters below. So -Z credentials, then -Q. So let's go ahead and do that here. I'm going to up arrow to get to it. There we go. And also, we will need to get the total number of detected credentials. So in the other video, we learned that we can pipe things to NL for new line, and it should give us that number. Okay, and you should get 75 in here because there's some that aren't in any of these numbers. So 79, you have to subtract that out of there. And then also up here, 3, 2, and 1, subtract those out of there, and you should get 75 as that the total number. Okay, and next one is task number 5, advanced filtering options, contains matches in fields. Accomplishing in-depth pack analysis sometimes ends up with a special filtering requirement that cannot be covered with default filters. TShark supports Wireshark's contains and matches operators, which are the key to the advanced filtering options. You can visit the Wireshark packet operations room task 6 if you're unfamiliar with these filters, or you can check out my video. A quick recap to the Wireshark packet operations room. It goes over what it is, contains, search a value inside packets, case sensitive, similar to Wireshark's find option, matches, search a pattern inside packets, supports regex, case insensitive, complex queries have a margin of error. Note the contains and matches operators cannot be used with fields consisting of integer values. Tip, using hex and regex values instead of ASCII always has a better chance of a match. Extract fields. This option helps analysts to extract specific parts of data from the packets. In this way, analysts have the opportunity to collect and correlate various fields from the packets. It also helps analysts manage the query output on the terminal. The query structure is explained in the table given below. So we have main-t fields target field-e, then field name, then show field name-e header equals y. Note you need to use the -e parameter for each field you want to display. So remember that. You can filter any field by using the field names as shown below. So -t fields, -e, etc., etc. Okay, here's an example that we're going to grab out of here. All right. So let's plug it in and see what it looks like inside of TShark here. Awesome. Shift IP and then destination. Pretty clean there. Contains. Okay, we already know what this one pretty much consists of. Search for value inside packets. Case sensitive, similar to the find option in Wireshark. Example, find all Apache servers. List all HTTP packets where the server field contains Apache word. HTTP.server contains Apache. Okay, and it's going to look something like this. So let's see if there's anything inside of here. We do have something. Okay, cool. The next one's going to be over matches. We read about that earlier. Search a pattern of regular expression or regex. Find all PHP and .html pages. For the example workflow, list all HTTP packets where the request method field matches the keywords get or post. Okay, and there's usage here. All right, so let's go ahead and copy and paste this inside of our terminal here. Clear this out. So there we go for that information. So you have get. Okay, pretty nifty, and this is pretty useful. Once again, question time, pause the video, try to answer these yourself, then come back to the video, and we will step through it together. Use the demo.pcapng to answer the questions. What is the HTTP packet number that contains the keyword cafe? So if we go and check our notes here, remember we can use the contains, the search for value side packets, case sensitive, similar to Wireshark's find option. All right, so to do that, we're looking for the cafe here. So we have the -y http dot server contains cafe in all caps. And you can see that number 27 will be our answer for that one. Next one, filter the packets with get and post requests and extract the packet frame time. What is the first time value found? So for this one, you got to use matches. So you have to use additional parameter, which is that -e, right, for these fields, and then you put that the field in there that we're looking for. So you can use this hint here, and you can see that you want to extract this field using -e frame time. So if we go and take a look there, we can see how that looks. Okay, so we're looking for the get post, and then -t fields -e frame time, enter, and there we go. We need this first one here, so we'll go ahead and grab that and plug it in as our answer. All right, task number 6, use cases, extract information. When investigating a case, a security analyst should know how to extract host names, DNS queries, and user agents to hunt low-hanging fruit. After viewing these statistics and creating an investigation plan, the most common 4 use cases for every security analyst are demonstrated below. If you want to learn more about the mentioned protocols and benefits of extracted information, please refer to Wireshark Traffic Analysis Room or check out my channel, see if I have a video over it. This is how you extract host names. Okay, so fields -e dhcp dot option dot host name, and let's go and plug it in to extract that information. There we go. So there's all of our host name there. There's quite a few of them, looks like. Pretty neat. Clear this out. The above information or example shows how to extract host names from DHCP packets with Wireshark. However, the output is hard to manage when multiple duplicate values exist. A skilled analyst should know how to use native Linux tools / utilities to manage and organize the command output. See, they're piping everything into things we've learned about before using Linux command line. Okay, so they're doing the same thing here, except they're piping it into awk and f sort-r. I'm assuming that's, I think it's reverse order, then unique -c, and then sorting it again. So let's go ahead and copy and paste this over. There we go. So now this is a lot cleaner than what we saw earlier. All right, so we keep building on what we've learned before in other videos, and that's why I stress that you need to be comfortable with the command line and using the command line tools at hand because you can reference them in other tools such as TShark, right? Now the output is organized and ready to process / use. The logic of the query is below. Okay, once again, it's our main query, extract the DHCP value, remove empty lines in F. Okay, sort recursively. Okay, sort recursively by handling the values, and then unique values, but calculate how many, or but calculate and show the number of occurrences, and then final sort process showing output results from higher occurrences to less. Very cool. I like how they break it down like that. Extract DNS queries. Okay, so they're going to be using this field here called dns.query.name, and they're using the same tools here, it looks like. So let's go ahead and follow along here. So once again, they are piping this into other tools that we should know about by now, or you should at least get familiar with the Linux command line and utilize these tools to make your stuff nice and neat, in case you have to use this in the real world or in another lab environment or CTF, what have you. So this is nice and clean there. The next one, user agents. So the same thing here, except for referencing this http.user agent field, and then we're going to use our tools again to clean up that information. Okay, plug this in, similar information. Okay, now, like I said, if we don't have all this in there, it can look pretty crazy, I'm assuming. Yeah, so look at that, a lot of stuff here. Okay, that should wrap up that part. And then once again, try to answer these questions yourself and then come back to the video and we will continue on. All right, let's go ahead and wrap this up with the last set of questions. Use the hostnames.pcapng
file to answer the questions. What is the total number of unique host names? So let's flip back over here and check our notes. And to get that information here, we can use the dscp.option.hostname, pipe it into awk nf sort -r unique or -c, pipe that into sort -r, and then an L for new line, so we can get that count. Okay, and then we see that 30 should be our answer there for that one. Next one says, what is the total appearance count of the prus-pc hostname? So we can pipe this into grep to find that particular information here. So pretty much the same query as above, and then grep and pipe it into new line at the end, so we can get that count. So okay, so we're filtering on that information using grep, and we can see that 12 is listed in here. You also need to remove unique. Okay, we had unique in the first one, and we removed it from the second one because we need to see the total amount of appearances that this shows up in there. Use the DNS dash queries PCAP to answer the questions. What is the total number of queries of the most common DNS query? So let's go and find that here. And for DNS, we could use the, oh, I didn't put it on there, but I'm just going to just up arrow to get that one. So I've already done it. Okay, we're going to use the DNS option as we tried out earlier. So we have dns.query.name, pipe it into awk, sort, then unique, and then sort at the end. And at the top here, we can see 742 for this db.roads.edu for our answer there. Okay, and the last one here, or the second last one here, we're going to look at this user agents PCAP file, and then what's the total number of detected wfuzz user agents. So if we take a look at our notes here, we're referencing this http.useragent, and then piping it into awk, sort, and then grepping it with the wfuzz. So let's go ahead and do that here. Clear this out. Paste. We have the new line there at the end, so we can get that count of it, and it's going to be 12 for our answer there. I wonder if we can, if it makes a difference if we take, I have two sorts in there, so I wonder if that's just a duplicate I accidentally put in there. Not, I can't remember. Let's take this out. Yeah, so it doesn't even matter. Took that extra sort out of there, and we still get the same results. Okay. It says, what is the HTTP host name of the nmap scans? Enter your answer in the defang format. So let's go ahead and do that here. And once again, or we're going to use this -e and take a look at http.host, and then awk nf sort -r unique c, and then sort it again, and then we're going to grep on nmap to pull that information here. Now you don't need to grep on nmap, but if you want to look at everything in this, you can just take that out and scroll through here, and you can see nmap referenced side of here, and you can see the answer is in there. But if you don't want to look at all that extra stuff in there, you can just grep it into, or pipe it into grep, and then nmap, like so, and you'll get an answer here. This .129 IP is what we're looking for here. Now, I know it says host name there. It's a bit confusing, but anyway, so plug that into CyberChef, defang it, and then plug it in as our answer there. So now let's wrap this up. Congratulations, just finished the TShark CLI Wireshark features room. In this room, we covered how to implement Wireshark security features into the TShark CLI, advanced filtering options, and use case examples. We now invite you to complete the TShark challenge rooms. So we have the first challenge is teamwork, and the second one is directory. And I'm sure we'll be covering those in this particular pathway. So if you take a look here, and yes, that'll be the next one's coming up here. Challenge 1 and then challenge 2. Awesome. So we are done with this. Hopefully you're able to follow along and take notes, because we went over quite a bit here in this room. As usual, thank you for your continued support. If you're enjoying the content on this channel, be sure to hit that like button, comment below, and also subscribe to the channel with the notification bell so you know every time I upload a new video to the channel. As always, thanks for watching, have a nice day, and I will see you in the next one. Also, don't forget, if you want extra practice, take a look at this malware traffic analysis website here. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video.
Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video, we are on TryHackMe SOC Level 1 Learning Path, Network Security and Traffic Analysis module. This is the TShark Challenge 1 Teamwork Room. Put your TShark skills into practice and analyze some network traffic. This room is completely hands-on practical skills here, so hands-on keyboard skills here. All right, so all you have here is the introduction, and then you have the case teamwork here. Okay, so let's go ahead and see what they're talking about. Before we dive into it, be sure to hit that like button and subscribe to my channel if you're new here. Task 1 Introduction. This room presents you with a challenge to investigate some traffic data as a part of the SOC team. Let's start working with TShark to analyze the captured traffic. We recommend completing the TShark Basics room and TShark CLI Wireshark Features rooms first. So check out my channel for videos related to those two rooms, which will teach you how to use the tool in depth. How to start the machine, click this green button over here that says Start Machine, and then it'll open up in split view. Note, exercise files contain real examples. Do not interact with them outside of the given VM. Direct interaction with samples and their contents, files, domains, and IP addresses outside of the given VM can pose security threats to your machine. And that's very valuable information to take into this, okay? So just imagine that you are investigating this in the real world, right? Investigating a PCAP that can possibly have suspicious or malicious indicators of compromise in there. Well, you don't want to analyze those on like a production machine, right? You're going to take that into a lab environment, or maybe you're doing a home investigation and you have your own home lab setup. Well, you open that up in VMware and open that up in one of your VMs and just fire it off in there. Start investigating, okay, so that you don't accidentally infect your own machine. Something nasty here. But anyway, task number 2, case teamwork. An alert has been triggered. The threat research team discovered a suspicious domain that could be a potential threat to the organization. The case was assigned to you. Inspect the provided teamwork.pcap located in the desktop exercise files directory and create artifacts for detection tooling. And then your tools, of course, TShark, and then VirusTotal we're going to be using as well. Answer the questions below. Investigate the contacted domains. Investigate the domains by using VirusTotal. According to VirusTotal, there is a domain marked as malicious/suspicious. And then you have some questions here to answer as you're going through here. Remember to have that investigative mindset, and you'll come to realize that as you're going through these particular questions. All right. So if you flip over to the VM real quick, have it open inside of this full screen mode here, and there's our PCAP right there. All right. So go ahead and have at it. And also be sure to check your notes, or you can reference these other rooms here. So you have basics pulled up, and I have the other room, the CLI Wireshark Features, so you can reference these inside of here. But you should also have notes if you've been following along with my video series. You should have your own notes here that you can reference, okay? Anyway, so go ahead and try to answer those questions and then come back to the video and we will step through everything together. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Welcome back. Hopefully you're able to figure these out yourself. If not, that's fine. We will step through the process together. Let's take a look here.
What is the full URL of the suspicious malicious domain address? Enter your answer in defang format. Remember, we can use CyberChef to defang URLs and also IP addresses of that nature. So let's flip back over here, and here's our PCAP here. This teamwork.pcap is going to be what we're going to be taking a look at. So let's clear this out and take a look at some process here. So we already know we're looking for like a domain URL of that nature. So we can use this DNS inside of our filter here, and right away we get something down and dirty output here, and we can see that this PayPal one looks highly suspect, right? It's referenced several times in here, and it looks weird on top of that. See, paypal.com, and then a bunch of other random crap after that. Okay, so that right away just shows like red flags to me. Okay, to me it looks like they're trying to pretend to be PayPal here to fool the victim into doing something they shouldn't be doing. So let's clear this out. Since we know that information, that's probably most likely what it's going to be malicious in here. And also you can use OSINT tools out there like VirusTotal, of course, to look it up and see if there's any hits on that particular domain, and other OSINT tools as well. There's URL scan and a bunch of others out there you can use. But anyway, so here's other ones that you can look at cleaner output. Okay, I'm going to use this one here since this is like one of the best ones that you can probably build out. Okay, so now we have everything just down to what we need here, and there's 19 occurrences in here, right, of this particular domain in question. And that's the one we're going to grab here. So just go ahead and copy that, and then you can plug it into CyberChef here and get that particular defanged format. So just copy this like so, and just copy that over as your answer. Plug it inside there. Now remember, you'll have to put this HTTP in front of it. So remember to do that. Otherwise, it may not take your answer. So on top of that, the next question says, when was the URL of the malicious/suspicious domain address first submitted to VirusTotal? Okay, so if we flip over to VirusTotal, you just go in here and just search for it, right? So if you do it this way, you will not be able to see that answer in here or that information here. You won't see the history, which is odd, right? But if you go in here and you add in HTTP and the rest of it here, you can see it under details, under first submission, and then we can see it here, right? So there goes our answer for that one. And the next one says, which known service was the domain trying to impersonate? Well, we saw PayPal in there, so that's a given one there. Next one says, what is the IP address of the malicious domain? Enter your answer in the defanged format. So if we go back and take a look at our original down and dirty one here, we can already see that there's several IPs listed inside of here, right? And we need to look at this one. So what we can do is clear all this out, and we can try to pipe this into grep and just grep on PayPal, since we already know that's the malicious one in question. Hit enter, and that'll help us slim this down a little bit more. So as we're reviewing this, and you can take a look at a few of these here, and you can see that this 184.154.127.226 appears to be the one we are looking for, right? Obviously, if you see the other ones in here, you're gonna have to do some digging on those, like some research on those to make sure they're not malicious or anything like that. Okay, so if you look this one up inside of an OSINT tool, something like VirusTotal, you should get some information back regarding that, right? So you can see there's no hits on this particular IP address, but if you go back and take a look at this domain here, maybe you can see that the IP may have shown up in here or not. With this one, what you can do is get rid of the HTTP stuff here, hit enter, and it doesn't want to work correctly. So let's just do it this way. Okay, get rid of that, and then we'll go to details here, relations, and then you can see the IP address listed here, right? That's the one in question. So that's another way of doing it. But anyway, so as we are conducting our investigation, since we know that that's the suspicious domain and IP address in question, for this initial one here, we can pipe this into grep. Again, this is just some additional tidbits here as you're doing an investigation. Okay, so now we just need this one, right? After we get that, our query squared away, we can put this into a folder or a file, right? So we'll just call this sus domain dot txt. There we go. Cat it. So now we have this as our evidence or proof or for our notes or whatever, right? If we are doing this in like the real world or something like that. You can do this for anything that you think you should be tracking. Okay, that's just one example. You can do it for the actual IP as well. Okay, so if we wanted to do that, um, you can do something like, I just forgot what it was. Let me go back and check my notes real quick. I believe it was this one here. The one that, there's one in here that, okay, well, you can do something like this as well. You can just put this into like a file or whatever to reference later on, but it may be later on in this task here that I'm going to get to. So we already have the answer for that one. Next one says we need to get the email address and then put it into FANG format as well. So right away, we're going to probably look at HTTP stuff, right? So remember in the other videos, as we're going through learning how to use TShark, we can use this filter here, HTTP, and then contains. Then you can look for .com, so you know that you're looking for an email address. An email address is going to have that .com in there, right? So you can start off by doing this, and then it should give you some results here to reference as you're scanning through these results and reviewing them. You can see that this application, et cetera, form URL and code is mentioned. You can see this login.php. Now, to me, this looks like this is some form of login page. Well, with login pages, you're going to have to use like a username or like an email address and password to log into the system, right? Or a web application, web server, what have you, website. So you can use that information to do some more investigation. So you can pivot off this information to get that email address in question. So let's go ahead and clear all this stuff out of here. And what you can do is use frame and then contains login.php so you can dig into that particular file there. And this .v should give us more information. I believe that stands for verbose, if I'm not mistaken. So as you can see here, this looks like the actual Wireshark pane if you're looking in Wireshark, right? And as you're scrolling through here, you'll see that you can find the information on the email address in question. Here you can see a post request to that, right? And you can see the forum stuff mentioned again. And then there's the malicious domain in question. And then you can see this user equals Johnny5alive@gmail.com. So, and then you can also see the password here. Browser information, you can see the operating system, stuff like that. Okay, so this appears to be what we're looking for. So grab that and then plug it in into CyberChef, or you just plug it in manually and then just defang it that way. So remember, put it in this format here. So Johnny5alive@gmail.com, and don't forget the open and close brackets there. Okay, so that should be it for that one. And also remember, if you're going to take notes for this in like an actual investigation, you can pipe this into grep once again. Okay, and then you can either put that IP address in or that email address in there by itself, or you can just use something like at gmail.com. Okay, like that, and then press enter. Now we just have that information here. So you can put this into a file. So we'll just say sus email.txt. Okay, and then we can cat it, make sure we have everything in there. Bam. So now we have everything in there that we should need for our investigation if we need to do anything else or to reflect on or reference our notes as we're going through this investigation process. And that should be it, right? So remember that you have to go back and reference these filters, these display filters and such. I for sure could not remember all of them. So hopefully you took good notes and you can reference them, or you can just go back to those two rooms that we did before about TShark and you can reference those as well. And you can also reference Wireshark filters. But yeah, so you should have some notes like this, make easier for you to reference, and then you can build out your queries and such through that way. Okay. Also, I'm going to include a cheat sheet for like Wireshark filters. I found one online. I believe it's this one here. So you can use these filters and stuff like that and make it easy to get to, right? And also, like I said, you can go back and reference those rooms. So this one is one of the TShark rooms, the TShark, the basics, and it goes over a lot of this information, explains it in great detail in case you forget anything. Like I said, I don't use these tools every day, especially TShark, anything like that. So it's good to have these in like a notes section or something like that. And also, this is the CLI Wireshark Features room. You can also check out my video on that, and it breaks down everything here of what everything does in order to build out your queries. Okay, and I think that's it. Yeah, there's this Wireshark package operation has a lot of good information here as well for using these protocol filters and such. So you can build out your query using these Wireshark filters to reference. Okay, so a lot of good information here. But anyways, we are done with this particular room. The next one's going to be over the directory, TShark Challenge 2 directory. All right, so the rest of our video. If you enjoyed this video, found it valuable, be sure to hit that like button, comment on the video. What was your best part? Did you struggle anywhere in here? Do you have any helpful tips for everybody else that's viewing? Subscribe to the channel and hit that notification bell so you know every time I upload to the channel. As always, thank you for watching. Have a nice day, and I will see you in the next video. Also, one last thing, remember that you can go to this malware traffic analysis if you want some more practice here along with Wireshark or TShark to analyze these PCAPs. Okay, I highly recommend going through and doing some additional homework here. All right, Abe walks you through some of these things inside of here. Right, it gives you some questions down here to answer. Just helps you out in your career. Right, remember, hands-on keyboard skills is what a lot of employers are looking for. Okay. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe, SOC Level 1 Learning Path, Network Security and Traffic Analysis Module, TShark Challenge 2 Directory. Put your TShark skills into practice and analyze some network traffic. Now, this is the second challenge to the TShark area inside this particular module on TryHackMe. We're going to go through and analyze another PCAP file and answer some questions. So before we dive into it, be sure to hit that like button, comment below on your thoughts and opinions of the video, and then also subscribe to the channel with the notification bell if you are new here. Let's go ahead and dive into it. Task 1 Introduction. This room presents you with a challenge to investigate some traffic data as part of the SOC team. Let's start working with TShark to analyze the captured traffic. Recommend completing TShark Basics and also TShark CLI Wireshark Features rooms first. Also check out my channel for videos related to both of these rooms. Okay, so make sure to complete these two rooms first so you know how TShark works in some way or another. Also, if you want to start this room VM, just click that green start button over there, which I've already done. So we're ready to start. And be sure to follow the directions here. Don't analyze this stuff outside of the lab environment or whatever, right? So don't interact with files, domains, IP addresses, okay? Be smart about it. Task number 2, case directory curiosity. An alert has triggered. A user came across a poor file index and their curiosity led to problems. The case was assigned you. Inspect the provided directory curiosity PCAP file located here in the exercise files folder and retrieve the artifacts to confirm that this alert is a true positive. Your tools, TShark, and then also old trusty Aristotle there. So we got questions down here as usual. So it says investigate the DNS queries, investigate the domains by using VirusTotal. According to VirusTotal, there's a domain marked as suspicious, malicious. What's the name of the malicious, suspicious domain, etc., etc. So this is similar to the first challenge room, this first part at least, and then we go into some ASCII stuff down here at the bottom. All right, so as usual, go ahead and try to answer these questions yourself, then come back to the video and we will step through the process together. So be sure to reference the TShark rooms and also the Wireshark rooms. We're going to be using those Wireshark display filters. Also be sure to take notes as you go along here, and then also be sure to use any type of cheat sheets you may have available, whatnot. Okay, so go ahead and try answer this question yourself, come back to the video, and we'll step through it together. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking. Enjoy the video. Let's take a look at these questions. What is the name of the malicious slash suspicious domain? Enter your answer in the fanged format. Remember, we can use CyberChef to defang URLs and also to defang IP addresses. Right off the bat, we know we're looking for a DNS query or a domain in this instance, right? So we're going to use that DNS option as we're going through here. Now, we already know off the bat we can use just TShark out of the box like this, but it's going to bring back a bunch of extra stuff that we probably don't need. But you can also find the answer through this by sifting through all this information. But you can see that it's a mess. There's a lot of stuff to sift through here. So I'm going to clear this out. And we're going to use a similar query to what we already used before in a previous video, okay, which is going to be this one here. So we're using this -t to designate which fields we're going to use, -e, and then we're going to use this dns.query.name. We're going to pipe it into awk, nf, sort, and you can see the rest there. All right, remember to reference your notes so you know what these things are doing here. Okay, this explains what they are doing. And I'm going to paste this inside of here, if it lets me. Okay, let me try to copy that again. Okay, so this should give us a lot cleaner output. Here we go. So right off the bat here, we can see a funky looking one, which is this one right here. And as you plug this into your OSINT tools out there, such as LargeTotal here, you'll see that you got a couple hits here and you see some other information. So let's go back to our VM real quick. And this appears to be the one that we're looking for here because it's already been flagged by VirusTotal as malicious several times inside of here. Okay, so that's the one we're going to go with. And remember, you can flip over to CyberChef to defang things. So I'm going to clear this out, paste this in, and you have the defang format down here in the output, and just plug that in as your answer there. Next one is what is the total number of HTTP requests sent to the malicious domain? Now with this one, you can click this hint here, and you can see that you're going to be utilizing this particular filter in your query. So let me bring that up real quick. Okay, so I'm going to scroll down a little bit. And here's the query I used. All right, so -y, and then we're going to use this http.request, and also we're going to use that http.request.full_URI that was referenced inside of this particular hint here, okay? And we already know what the suspicious domain is, right? So I just pipe that into grep, and I'm going to grep off that domain, and then I'm going to use the new line at the end there to count for me, okay? So I'm going to clear this out. If I can spell, plug it in here. Count there is 14 as the total number of HTTP requests. Okay, and you can also analyze this information here. Right off that, you already see some funky stuff that it might be doing here. So you have this vlauto.exe that could be of interest. Um, see, it's in here again, down here at the bottom. So just make sure to pay attention to things such as that as you're going through this analysis. For this one, where it says, what is the IP address associated with the malicious domain? Enter your answer in defang format. Remember, use CyberChef to defang it. So to get this one, this is what I did here, tshark-r, the pcat file, and then I just basically piped it into grep, and I am grepping the malicious domain in question, and you can see it pulled back that information. And at the end here, we can see that malicious slash suspicious IP address in question. So that's how you get that one. All right, so we have that as our answer here, this 141.ip. Just plug that into CyberChef to get the defang format. And let's see, the next one says, what is the server info of the suspicious domain? Now, with this one, you'll have to use the -v for verbose, so you can pull that information. Because that makes it look like the Wireshark pane, right? So if you're viewing this in Wireshark, then you would see that information in one of those panes in that graphical user interface. Okay, so it's pretty much the same thing that we did up here, except we put this dash v in there to get additional context around there. Plug it in here. Okay, and then right at the end here, you can see what we're looking for here, Apache, et cetera, et cetera, et cetera. So we're going to grab this out of here and then plug that in as our answer. Next one is follow the first TCP stream in ASCII. Investigate the output carefully. What is the number of listed files? Well, we already know there's going to be XE in there that we're looking for at least, right? That was suspicious, what we saw earlier. So anyway, flip that over to our query here. And remember, in the other TShark room, we can use -D to follow the streams. Okay, so we are going to follow that stream like it says here to do, to follow the stream, the first TCP stream in ASCII. Remember, the first one's going to start with a 0, so that's why that 0 is in there. And then in dash Q, I believe, is to get rid of any extra noise that may appear on the output. So now that's a little bit more cleaner. You have to basically sift through here and try to identify those files. Well, we know we're looking for XEs, right? So one thing you can do is try to pipe this into grep like this and type in .xe, right, and see what it pulls up here. Okay, so there's that first one we already saw in there, and now doesn't appear to be any other XEs. I wonder if you could just try this as well. So we'll put dot and then a star. Anything in there? No. Okay, so I just wanted to test that out real quick. But anyway, so we're going to go back and take a look here at the output. So as you're scrolling through here, you'll come across there's going to be a total of 3 files in here, right? So if you take a look here, that we already see one, this VL auto, and then you can see another one up here called 123.php, and then right here, this vlauto.php is the last one. So that's going to be 3 of them. Okay, so that's 3, and then it says what's the file name of the first file? Well, we already saw that's going to be the 123. That was over here. That's the first one. Okay, and then also it says export all HTTP traffic objects. What is the name of the downloaded executable file? Enter your answer into Fang format. Okay, and we need to take a look at the HTTP traffic objects. And to do that, you got to use that export filter as we learned in one of those TShark rooms here. So I'm going to go to the query here, just dot that export objects, and then you're going to know that you're looking at HTTP, and then you just put it in whatever directory that you're collecting this information in, okay? And this, I'm just going to put it in the same directory that we're in. So do it this way here. Now I'll do ls, paste, there we go. All right, so now we see we have all our files exported out of here. The question is going to be this vlauto.xe is the one they're looking for here, right? That one that was downloaded because this is executable file and .xe's are executables. And to defang it, just put these open and closed brackets inside of there, and there you go. Now when you get the SHA-256 of that file, and to do that, you just basically run SHA-1 on the file, okay? So I'm just going to up arrow here, and then we already know we're looking for that vlauto.exe. Okay, so in front of this, instead of ls, we're just going to use SHA-256 sum, like so. Bam, now we have our SHA-256 here, using that nifty tool. This also works for other types of hashes as well. I believe there's MD5 sum too, so let's see here. MD5, I believe this is how you do it. No. Anyway, there's other tools you can use to get these hashes. So we're just gonna go with this one here, as it says in the question there. All right, so you can put this into VirusTotal as well, and you can see there's a lot more hits there. So let's navigate back over here. We already know the hash, so we have the hash there. Plug it in there as our answer. To search the SHA-256 value in VirusTotal, what is the PID packet value? So to get that, navigate back over to VirusTotal. It was actually in details. So .NET executable, just copy that and then plug it in as our answer. And last one says search the SHA-256 value in VirusTotal again. And what does the last line sandbox say? Now this one's going to be in behavior, if I'm not mistaken. So we have see last line's already in here.
scroll down a little bit to see what it flags it as. So it says the sandbox last line flags this file as malware Trojan. So plug that in as our answer, and we are done with that. So I'm going to copy that out of here. Okay, and then paste it in as our answer. Bam. So now we're done with this room. Also, remember, as you're going through here and collecting this information, okay, so if you want to collect this hash value, remember you can plug this into um, like a file. So let's say SHA-2 hash dot txt. So okay, ls, there we go, and then cat it. There we go. So like I said before, as you're going through this analysis, you're going to be able to collect valuable information, valuable IOCs, which is indicators of compromise, other evidence, things of that nature for your notes so that you can reference if you need to. And that's pretty much the end of the video. Also, be sure if you want to go to additional hands-on keyboard practice, you can check out the site called Malware Traffic Analysis. And then you can see these exercises are here. So just click in here and you can go through a plethora of different exercises to get more hands-on keyboard skills. So anyway, that's the end of this video. If you enjoyed this video, found it valuable, like, comment, subscribe with the notification bell, and you will know every time I upload a new video to the channel. Have a nice day, and I will see you later.